name is Matthias Urbaner, and I'm in Math 2000 here at the Challenge Program. The problem I'm going to be working through today involves four parts. The first of which is simply to state the chain rule. Now, the chain rule is one of the basic tenets of calculus, and is to use basically any time that you take a derivative that's more than just basic. And so the chain rule involves taking the derivative of a composition of functions. That is to say, when you take one function and you plug it into another as x to build a functionception, so to speak. So the chain rule simply states that when you take f of g of x, a composition of functions, the derivative is going to be f prime with respect to g of x times g prime of x. So if you say that g of x is just a variable, like a constant or something, then you would get just this, right, with g of x just a constant, and then if you have to add this in because it's not just a constant, because it will have its own impact on the final answer. If you think about it, when you take the derivative with a constant, you do the same thing, except that the derivative of x, which is the usual input, is just 1, so it doesn't really matter. And yeah, so there's a chain rule. F prime of g of x times g prime of x is the derivative of f of g of x. Now, the second requirement, or the second part of this problem, is to find the derivative of arctan of x, which is also tangent inverse of x. And now, for this, we're going to use the identity in calculus to get the derivative of an inverse function, and that is that the derivative of an inverse function, so d dx of f inverse of x, is equal to 1 over the derivative of the original function, the inverse of the inverse, so to speak, so f prime with respect to the inverse function, so f inverse of x. So going back over here to arctan, or tangent inverse, the derivative of that is going to be, we just plug it in here, 1 over the derivative of tangent, which we know to be secant squared, of the inverse tangent of x. However, we can take this a step further and make it a lot prettier to look at. And if we just have to remember our identities, which we look at secant, or tangent squared plus of x plus 1 equals secant squared of x. And so if we just take this, right, that's the same as that, so we plug this, or replace it with this. So what we get is that this will equal 1 over tangent squared of inverse tangent of x plus 1, right? And as we know, this is the same as that. So then, from the definition of an inverse function, we know that when you make a composition of a function and its inverse, then it will cancel out, leaving just what was on the very inside. So in this case, it's going to cancel out and leave us with 1 over x squared plus 1. And that's the derivative of inverse tangent. Now, the third part of the problem was to find the derivative of or to derive a function for finding the derivative of a composition of 3 functions, which is basically taking the chain rule and putting it into the chain rule. So as we have up here, the chain rule, the derivative of f of g of x is f prime of g of x times g prime of x. But now what we're trying to find is the derivative of f of g of h of x, mod parentheses. And so we can use substitution in a way to make this a lot easier, to make it more like something that we've seen before. If we just say that g of h of x is equal to j of x, right? So now this up here is going to be equal to the derivative of f of j of x. And that looks a lot more like something that we can easily take the derivative of, like here. And so now we know that this is going to be equal to f prime of j of x times j prime of x. And so now, here we have an answer, but it's not the answer that we're looking for, because j is just an intermediary step. We want this to be in terms of f, g, and h, or f prime, g, and So we come over here and we just plug it back in. So we combine these two. So we get f prime of g, or we have, sorry. So the derivative of j of x, we already have j of x equals g of h of x. So the derivative of j of x is, again, the chain rule. So that's going to be g prime of h of x times h prime of x. So now we take all this and we put it together, and so we get that the derivative of f of g of h of x is equal to f prime of g of h of x times g prime of h of x times h prime of x. And there it is. Yeah. And so now we have here for ED for easy access. So v dx of f of g of h of x to f prime g of h of x times g prime of h of x to h prime of x. Okay. And so now the last problem in this group is to basically bring together everything that we have figured out today or in this session. And the problem is to find the or to derive a formula, yes, to find the derivative of the inverse tangent of e to the tan x. And so we can use this formula to make this problem really easy, honestly. So we just get f of x is equal to tangent inverse of x. Then g of x is equal to e of x. And then h of x is equal to tangent of this. And then if we get the derivatives of each of these functions, we get that f prime of x is equal to, as we saw before, 1 over x squared plus 1. G prime of x is the derivative of e to the x, which is just e to the x. And then h prime of x is equal to the derivative of tangent x, which we know is secant squared x. And so, so what we do now is just take all of this and we plug it into there. So we get that this derivative is going to be equal to f prime, so that's 1 over g of h of x. So we're going to have 1 plus, and instead of x squared, we're going to have e to the tan x squared, which, as we know, is the same as e to the 2 tan x because of the basic exponent rules. When you raise something that's been raised to a power to another power, you just multiply the exponents. And then that is going to be times g prime of h of x. So it's going to be e to the, instead of x, tan x. And then times h prime of x, which is just secant squared. So then we take that and we put it all together, and we get that's secant squared of x times e to the tan x over 1 plus e to the 2 tan x. And that is the derivative of that. So thank you, and my name is Matthias Herbert.